Hello, today I'm going to talk about the analysis of a research article. The, the paper title is DART, which is Differentiable Architecture Search. And this research was recently released from a team at Carnegie Mellon University and DeepMind. And DART assumes that the space of candidate architectures is continuous, not discrete, and this allows it to use gradient descent approaches, which are vastly more efficient than the inefficient black box search used by most neural architecture algorithms. And here is the first part, the introduction part. At the very beginning, it just try to establish the territory, which is move one. And as we can see that the first sentence is that it offer the background information to state that the task it focused on is difficult. And then in the second sentence, it claims the centrality, which refers to growing interest in the topic, and and it tells the AutoML for designing the architecture automatically is becoming a hot topic. Okay, the next step is that it established the gap. In the first sentence, it claims the centrality, which describes the drawback of other methods. He, the paper said that the other methods are computationally demanding. And the second sentence gives us some example to prove that other methods have some shortcomings. And then the third sentence includes some then just includes some solutions which failed to solve the problem. And finally, it explains the reason why those ideas are not efficient and are not good. The third move is to address the gap. And in the first in this part, the first sentence claims the centrality, which proposes the new method called DART. And then in the second sentence, the paper introduces the novelty of DART, and like this. And also, this sentence uses the so that clause. It tells us that the architecture can be optimized with respect to its validation set performance by gradient descent. And the third sentence just tells the reason why Dart works. And then the fourth sentence made the comparison between Dart and other methods to prove the Dart is efficient enough. Formally, the introduction part, I chose the methodology part. And the first move is to establish the territory. And as you can see, the first step, it just introduced the structure of the paper and tell us the detail of the paper. And then introduce the paper, the way building the network, and also tell us what the types of the cell which will be generated by DART. Later, uh, this paper, this is the move two, which is to address the details of the DART. And and as we can see, I have um, make these words green, and those those sentences are all about cell structure, and then the second part just gives us the equation of intermediate node. And here, the first sentence is this part is also the details of the methods. The first The first sentence gave us the special operation executed in a cell, and later, this part is form is tells the form operations, and then makes the search, and later tells the way of making the search space continuous. And here is the equation tells the details of the methods. And here is also the details. And as we can say, here the first tells the relaxation methods, and can tell us at the end of the search what we need to do. And after introduce the relaxation, it also introduce the goal after the relaxation. And later it also tells the sign of training and the validation loss, and introduce the related parameters. After that, it also gives us a bi-level optimization problem, because the formal gives the equation of validation loss and the training loss. So here is the bi-level optimization problem, and later gives the related problem of solving the formulation. And later gives us the reason why solving the bi-level optimization is prohibitive, and at last give the solution to solve the bi-level optimization, and which is really clear for the readers in, yeah, just this equation. And later give us the inspiration from other work or related work, and also the observation of the practical work. And at last, give us the architecture gradient equation, and this is very important of this paper. And after that, tell us the way to reduce complexity of computing gradient descent to solve the problem we discussed at the very beginning. And this is the very last part, tells how to make approximation. There are two types of approximation. The first is the first order, and the second is second order, and it tells the details. And finally, after we do the above work, and here's how to derive the discrete architecture. And this paper finally just takes just 4 days, 4 GPU days compared with other methods, and which turns out that this method, which means our cars, is really efficient compared with other methods.